Hi everyone, this is our group project assignment for the subject MAT575 for the topic title Discrete Methods. Before I begin, let me introduce our group members. I am Nur Syamira Aina binti Head Ahmed, and with me Nurin Adila Yasmin binti Ali Shazli and Nur Umaira Syamila binti Muhammad Nazri. The discrete least square method is used to model the curve shape of a leaf by dividing its outline into a smaller segment and fit each segment with a polynomial curve. This method minimizes the differences between the actual data point and the predictive curve, allowing for accurate mathematical representation of the leaf in natural form. Calculations, including finding polynomial coefficient and residual, are performed in Microsoft Excel with high precision. This project demonstrates how mathematical technique can effectively model and analyze complex natural shapes.
Measuring the parameter of an object with an irregular shape, such as a leaf, presents significant challenge when using traditional method, like a thread or ruler, as this technique often results in inaccurate and inconsistent measurement. Therefore, a more reliable and systematic approach is needed to estimate the outline of such shapes. The least square method offers a suitable numerical techniques for this purpose by fitting the polynomial function to the segment of the shape. By dividing the leaf into smaller sections and applying the discrete least square method to each part, a more accurate approximation of the overall outline can be achieved. This study aims to evaluate the effectiveness of this method by comparing the estimate length to the actual measure value. The objectives of this project are as follows. Number 1 is to apply the discrete least square method to fit polynomial function to the segment of a leaf shape. Number 2 is to divide the leaf into several sections and determine the best fit polynomial equation for each segment. Number 3 is to calculate the outline of the leaf using the fit polynomial function. Number 4 is to compare the calculated outline with the actual measure parameter of the leaf. The last one is to evaluate the accuracy and effectiveness of the least square method in estimating outline of irregular shapes.
Now, let's look at the step we followed to find the arc length of a leaf using the discrete least square method. Step 1 was to sketch the leaf on graph paper. Then, we marked 12 points around the leaf outline. After that, we recorded these x and y points into a table. Next, we divided the leaf into 4 different sections. For each section, we used the discrete least square method to find its mathematical function using Cramer's rule. After finding the function, we physically measured the leaf perimeter using a thread. This gave us the actual length. Then, we calculated the exact outline of the leaf using our function. Finally, we calculated the error to see how accurate our estimated outline was compared to the actual measurement. This step helped us apply the method practically to measure the leaf shape. Now, let's talk about our scope implementation. First, our report focused on using the least square method to fit curve to data, which specifically is the discrete least square method for polynomials. We explained the basic ideas of curve fitting and how least squares is different from another method called interpolation. We also show how to find the linear least square method. Our report also explained how to use polynomial least square for degrees 2 or more. This includes how to find the right polynomial coefficient and shows examples. However, there are limits to least square methods. It's not the best choice for data that is very precise or super accurate. For such data, interpolation methods are better because they make the curve go through every data point exactly. Our report only talks about discrete least squares, not interpolation methods. Also, these methods assume that your x values are perfectly correct and only your y values might have small random errors.
Result and discussion. To calculate outline, we first found the polynomial equation for each of the 4 sections of the leaf using the discrete least square method. Each equation was in the form fx equal to a naught plus a1x plus a2x squared. Next, we calculate the derivative of each function and use the outline formula, which is the integral from a to b of the square root of 1 plus the square of the derivative of fx with respect to x. The outline for each section were calculated as follows. Section 1, we get 5.3438 units. Section 2, we get 7.6347 units. Section 3, 5.0984 units. Section 4, we get 7.2570 units. By adding all 4, the total estimate outline of the leaf was 35.3339 units. In comparison, the actual measured outline using a thread was 34.3 units, showing that the estimate value was lower.
So for the conclusion, this project applied the discrete least square method to estimate the parameter of a leaf by dividing it into a 4 segment and fit polynomial curve to each. The outline was calculating by approximating integral of the curve derivative. The estimate parameter is 25.33 units, was significantly lower than the actual measurement, which is 34.3 units, resulting in 26.14% error. This shows that while the least square method is effective for smooth curve fitting, it may lack accuracy for precise parameter estimation of a complex shape. It highlights both the method's usefulness and limitation in modeling natural form. That's all from us. Thank you for watching.